we will see how the client handles incoming signals from the CWP server. Here you can see the server running. You notice that it has now two clients on the frequency 1337, and I have the beacon application also running. That is the one client, and this application running here in the emulator is the other client. And the state of the connection is now connected, or actually it's line down, because that's what the protocol says. When you connect to the server, this state is connected, but when the server then replies with the frequency, it is then line down, the state of the connection. And now when I send a signal to that frequency using the emulator application, at this point the connection reader is now here in the read loop, and it's blocked here, waiting for something to arrive from the server side. And something will arrive when I send the signal, and the beacon will then reply. So we can see here from the server console what happens. So now this blocking read operation resumed. Something arrived from the server, because you can see here the beacon sending messages. Our application is now stopped here, of course, because of the breakpoint. So we are just starting to handle the first lineup message from the server side by reading all those bytes from the socket using the input stream. And we now did the reading. So we were here in the connection readers run when we initialized the connection and initialized the byte buffer, and then started the read loop. This already went around 2 times when the connection was made. First, the server sent the default frequency. Then our client saw that, okay, the user selected frequency was different. So the client sent the change frequency message. Then the server replied. And then we waited for the user to actually start sending signals. When I did, then the beacon got that message and started sending back line up, line down signals. And now we are here handling the first line up signal in the client side. So we read 4 bytes. That's according to the protocol specifications, the timestamp of the lineup signal from the server. We clear the buffer for possible previous data and put these new bytes there, and then start reading what we actually got. And this value 229224 is just a timestamp for the lineup signal. What that means, you can read from the protocol specifications. If the value is positive, this is a lineup signal. So we are going to change the protocol state to line up using this method here. So because now we are changing the state of the protocol, we have to do it protected by this lock semaphore, so that it doesn't accidentally happen in an overlapped way by the different threads. Then we change the state and using the handler, tell the protocol implementation, which is this runnable here, that it needs to handle this state change. So now we need to go to the protocol implementations run, which will be called because of this handler post thing, and put a like this. So now we are in protocol implementation run. Here, sorry, we will read the message value. This is basically the timestamp, lineup timestamp. Check what is our state. It was actually it was not line up, but it will be line up because this is the next state we are transferring to. So we are transferring to line up, and because we are in the protocol implementation run, it means that this state change came from the reader thread. So we can say that lineup by server is now true. Then, if line is not up by the user already, then we are actually changing the state of the protocol. If the user already would have put the line up, this fact that the server also wants to put the line up doesn't mean really that state would change. It would be that we are already in the lineup state, and also server said that we want to be in lineup state, but that wouldn't be actually a change in the state. So we wouldn't tell the listener that line is up. In that case, we would only tell to the server that, okay, server changed the state, but the actual state of the client wouldn't change. We already were in lineup state. But now the line was not up by the user, so we continue. We change the state. Current state is now next state. Then we release the log that we acquired here in the connection reader. So we acquire the log there and release it up here to make sure that in between this state change handling, no one else gets to tries to change the state before we handle the previous state change. Okay, and then we notify the listener, which is the model. So we can put also a breakpoint here to see what happens then. Okay, so we resume. So the model then is an observable. It sets its state to changed, so that when we call notify observers, actually observers are notified. Without this set changed call, that notification would not go ahead. So that is required. Let's see, for example, what the tapping fragment does with this notification. So we put a breakpoint here in the update method. So tapping fragment implements the observer interface, and basically that means this update method here. Okay, so again we resume and see what happens. Now we are actually again also here. New data arrived from the server side. As you remember, the beacon is there sending LineUp and LineDowns. So again, a message was read from there. So many things happening at the many time. That's the idea. What happens in a multi-threaded application. So we can check what happens here. Okay, now we read 2 bytes here. As you can see, because now the line down came. Line up is 4 bytes and line down is 2 bytes, because usually the line up time is smaller, so 2 bytes is enough. So now we read that timestamp. The duration of the line up is what is this value actually about, and we change the protocol state to line down. So this was happening now there in the connection reader thread. At the same time, then the main thread is handling the previous state change because the lock was already released, so this can now do that change. So again, press resume. What we can now see is that the reader thread handled the line down state and rolled back to the while loop and started again reading the next line up state change from the server or message. So again, we resume the application. We see that there is now data coming from there. So the line up is now read. And again, when I resumed, now we can see that now the main thread got to handle that observer notification update message about the first line up state change. So as you can see, the operating system is giving time slices to these two threads, and they get to execute whenever they get a chance. It's up to the operating system to decide when a thread can have a chance to run and when not. And of course, our logs also contribute to this scheduling of these threads. So you need to be aware of these concepts: threads, time slices given to threads, scheduling of the threads, logs that influence on when the threads can actually run and when not, when they are waiting for a log and when not, and stuff like that. So you need to read, if you don't understand all this, you need to read the readings in the background reading page in the wiki, and also in the specific doings related to threads, meaning doings 4 or 5. There are additional reading that you need to read in order to understand all these threads running, synchronization, and so on. Okay, but let's return back to the observer. So what the tapping fragment is doing is that it handles now the first lineup event. First, it toggles the server state symbol. So it checks from the messaging interface, did the server set the lineup or not, which just forwards this call to the protocol implementation, which returns this variable, Boolean variable, did the server set the lineup up or not. And the value is now true, of course, again, because the protocol implementation run here set the line up to true when the lineup event came from the protocol reader thread, and it was handled by the protocol. Okay, so now it can set this small symbol character on the screen to that one, indicating that the server line is up. Okay, and then we also changed the lamp image view to line up because the state of the line is now up. It doesn't matter if the line is up because of the user or server setting the line up. It is up, so then we need to change the state of the lamp to up. Okay, so now we can again resume the program. Remember that the reader thread already read the line down also from the network input stream. So that's why we are now here in the protocol implementation run breakpoint again. So if we go down here and see how the connection reader behaved, just to remind us what happened is that the first lineup was read here, then we went to see set the state of the protocol to line up, then 2 bytes line down was expected, so the read loop was reading 2 bytes, and we got that 2, and we changed the date to protocol line down, and then we went back here where we are now. But the line down still hasn't been handled by the main thread. still the reader can start reading new data. Now we are here reading the line down from the previous event handling loop. So the protocol implementation notified already the model about that line down, which happened in the protocol implementation run up here. The line down event came. I jumped over this breakpoint by resuming the application. It would have been nice to see also what happens here, but we can take a look at it now. So what happened in line down is that the current state was not connected, but line up. So we went to this else branch. So line up by server is not anymore true. Line wasn't set up by the user. So we changed the state from line up to line down, release the lock and tell the listener, and that's why we were already here in the model who is the listener, notifying the observers that now the line is down. As you can again see, debugging threaded application with breakpoints can be quite complicated because threads run whenever they run. You have no control over that. You may skip breakpoints because you were watching another thread doing something, and then you miss some piece of code that was executed, like I missed this line down here, how it was handled, and then well, as you can see, it's not so easy. Anyways, that is why you should prefer using logcats for debugging multi-threaded applications. As you can see, I have here these tags, which are always a class, and then messages here tell what the class is now doing. Reader has read 4 bytes, and then changing the protocol state to line down. Protocol gets this notification, then what the service does. This is from the doing 7, and so on. So you can see that these threads are doing their job interleaved, and then you just try to analyze from here what is happening and when. So we never promised that it's easy. It's challenging, but you have to do it. You have to do multi-threaded programming, and that is a challenge by itself. That's why understanding what happens when you do thread programming is important, and that is what you are learning here. Okay, so let's resume the program again to see what breakpoint is met next. The tapping fragments update again, because tapping fragment is an observer. So what are we now handling here? The line down event. The connected event is actually handled the same way, so that's why we can have these 2 cases at the same place. So we toggle the server state symbol again by checking what is the state of the server's lineup variable. It is now false, so we set the symbol to this one, and then set the image resource to line down. The lamp is now line down. So then the next message is again handled by the main thread. Remember that the reader thread is there reading the data from the server connection all the time when it has the chance to do that, and notifying the protocol implementation using handlers post call that now you should handle this state change, and this keeps repeating as long as there is something arriving from the server. And again, now the line is going up. Okay, so we handle LineUp event as we did before this. Again, we can resume, see that now the LineUp is handled by the model and then the observers. So we continue resuming the application. Now again, we see that we are going to the read loop because new data is arriving soon. So we start reading it. Here it came. Again, the observer here got the chance to handle the state change update from the observable. Again, a new message arrived to the protocol implementation from the reader thread because it called the handler post, and so on. So this all is continuing as long as there is stuff arriving from the server side. Again, the reader is reading new values from the socket, and this all continues as long as the server keeps sending LineUp, LineDown events to the client. Okay, so this code walkthrough showed you how the reader thread keeps running in its own run loop, reading either 4 bytes or 2 bytes from the network input stream, depending on what should be expected to come there next, and changing the state from LineUp to LineDown, depending on this what is expected to arrive next from the socket. And then the change protocol state takes care of the lock and notifies the main thread and the protocol implementation there that now you should handle this state change. Effectively, as mentioned, this results in the protocol implementation run being called. So there you handle this notification from the reader thread that please handle now this new information from the server. And what is important here is that we release the lock after we have handled the state change, so that the reader can then again, when it wants to change the state, first lock the state variables and then do the change, and then notify the protocol implementation, which will then again release the lock. So there's a cooperation between these two classes, protocol implementation and reader. They are running in separate threads and they cooperate like this, using the handler post and this lock and these state variables to get information from the server what should be the state of the application. Okay, all this, how to implement this is of course instructed in the doings. The cooperation of these threads is first implemented in doings 4 without the networking, just using a timer and threads. Then from doings 5 you will start bringing in the networking code. First only the reader, how to connect to the server and start handling incoming data from the server. Then later on in doing 6 you will actually then implement how to send information to the server using the connection writer class, which we will discuss in another video. Okay, that was it.